Greetings to one and all listening to this video. I am Anthony Sabha, working as an assistant professor in the Department of Artificial Intelligence and Data Science, Kumaraguru School of Innovation, India. I am presenting the work titled Sarimax Forecasting for Horticultural Products. And the presentation flow goes like introduction, problem statement, research objective, literature review, the methodologies adapted in this work, results and discussion, conclusion, and references. Sales forecasting enables farmers in estimating future revenues by predicting the quality of a product or a service that the market or the company is likely to sell in the upcoming days. Hence, it is aimed to enable farmers to make informed decisions regarding the production adjustments, ultimately reducing the waste and maximizing the profits. And this work is to develop accurate sales forecast for horticultural products for optimizing agricultural production and ensuring the market alignment. To meet the problem statement, the research objectives defined are analyze the stationarity of the sales data and address non-stationary issues, and to develop a Sarimax model for predicting the annual sales, evaluate the performance of the Sarimax model using the key matrices mean squared error and mean squared error, and finally provide actionable insights for the farmers to optimize production on forecast demand. There exist several literatures to forecast the profits and sales in various business sectors. I have listed few where Su et al. In their work used ARDL as well as lasso regression in order to predict the profits from the quarterly profits data, whatever they have recorded in the year 2006 to 2019. And lasso regression outperforms well because of the nature of penalizing the large coefficients. And Sridevi et al. They employed ARIMA model in predicting the profits from the quarterly data of a retail store. And Koichi et al. They have they have employed the neural network forecasting models RNN and LSTM to forecast the price of agricultural products. And Karina employed ARIMA model in forecasting the demand of newspaper by considering the quarterly sales of newspaper. And Sudeshna Ghosh also employed ARIMA model predicting and forecasting the exports of cotton sales, and it has been observed from the literature that the ARIMA and the LSTM models outperforms in forecasting the profits or sales or export quantities, etc. And still, it was felt that since agricultural products are seasonal, the seasonality factor may be given importance in forecasting because as the season changes, they have a huge impact on the data as well. And therefore, I have introduced the seasonal forecasting model in this work. The proposed methodology has the following phases. The first phase is data collection and pre-processing, where the avocado sales dataset is considered in this work, and the avocado sales between the years 2015 and 2020 are considered in this work. The gathered data consists of missing values, and the missing values are addressed by employing statistical strategies, and there are 33,045 samples, and the independent variable used in this work is the average sale. And the second phase is stationarity checking. For any time indexed data, this stationarity check is mandatory because if the data exhibits non-stationarity, then whatever forecast or prediction done by the model will not be a stable one. And there are several strategies to detect the existence of stationarity in a time indexed data. And in this work, augmented Dickey-Fuller test is employed. And this ADF checks for unit roots which indicate whether a time series has persistent trend or non-stationary. The p-values are checked, and in this work, the p-values are below 0.05, which suggests the time series does not have a unit root and it is stationary. And uh, even when including the seasonality component in making forecasting, there exists another model, Sarimax, and we wanted to include the exogenous variable as well, and hence the Sarimax is employed in this work. And the model is built with Sarimax following the auto regression of order 1 and differencing of 1, and the moving average order is also 1, and the seasonal components and the tuning parameters are also fine-tuned in this model development. And here AFT is the trend polynomial, and theta q of L is the non-seasonal moving average lag polynomial, and theta t of Ls is the uh, seasonal moving average lag polynomial. And the model is evaluated using the performance matrices root mean squared error and mean squared error. And figure 1 visualizes the differenced time series data where the trend is removed by applying symbol differencing. And the figure 2 visualizes the time series decomposition, where this is the virginal signal, and the second plot shows the trend component, and the third plot shows the seasonal component present in the time series data, and the fourth subplot shows the residuals. And the table 2 gives the summary of the Sarimax model, where the models are built with autoregression with lag 1 and autoregression with lag 12. While looking at the p-values of the coefficients of both lags, the p-values are below 0.05, which shows that the coefficients are sufficiently good enough to build the Sarimax model. And the lower average price as well as the upper average price of avocado sale is forecasted in this work. And this visualization shows the residual, the diagnostics of the Sarimax model. The residuals here look like a white noise and are quite close to the standard normal distribution. And there are no significant autocorrelation visible in the correlogram. And because of all these factors, the model is able to give a mean square error of 0.01, which is reasonably good with a root mean square error of 0.1. And the figure 4 visualizes the one step ahead forecast of avocado sales, and figure 4 visualizes the forecasting for out of sample data till the year 2029. And the observation is that the sale of avocado remains consistent. It is not vertical fall or it is not vertical high. It is consistent in the market. Accordingly, the farmers can plan for the production of the avocado fruit and the marketing strategies they can devise for the sale of avocado. The Sarimax model effectively addresses the challenge of forecasting avocado sale by incorporating the seasonality and the exogenous factor. And this approach provides farmers with a powerful tool to optimize the production, and hence the wastage of the production are getting reduced, and the market demands are also met. The future work will focus on validating the model with live data sets incorporating additional independent variables like location and population to enhance the decision made by the model to the formats. And these are the references which I have gone through and used in this work. Thank you.